What is the rational root theorem? Great question. Glad you asked, because that's what we're studying today. So first, we want to know, why is it important though? Why do I care about even learning this before I bother figuring out what it is? So why is it important? It helps us narrow the search to find rational roots or roots of polynomials. What is the rational root theorem? So if we have a polynomial, that's what this is telling us. This is just a polynomial. Polynomials are what we have been dealing with in this unit. So if we have a polynomial that has integer coefficients, so remember, integers are whole numbers, but they can be positive or negative. And P over Q is a rational zero in lowest terms of P, then P is a factor of the constant term, a sub 0, and Q is a factor of the leading coefficient, a sub n. If you're confused by that, what that is telling us is that our rational roots are possible rational roots are going to be factors, that's an S, of the constant term divided by the leading coefficient. And the constant term that's always the term that has no x with it, or no variable. The leading coefficient, that is the term in front of the x with the highest degree. That's what our possible rational roots are. Now keep in mind, when we're saying factors of the constant term over the factors of the leading coefficient, the factors can be positive or negative. For instance, like the number 5 has factors of 5, -5, and 1 or -1. Those are all factors of the number 5. All right, let's look at an example. That'll hopefully help us. So we want to find all the roots of this polynomial. First thing we would actually try to do is try to factor it. But in this case, I can see that if I tried to group, there wouldn't be anything that I could take out of these two terms, and then that's not going to work with this. So grouping's not going to work. So first, let's list all of the possible rational roots. That is my constant term. My leading coefficient is 1. What are the factors of 3? So 3, I can have plus or minus. Sorry, let me rewrite that. I could have plus or minus 1, because 1 is a factor of 3, or I could have plus or minus 3. The factors of 1 are just 1 and -1. So all of these could be divided by plus or minus 1. What does this lead us to? So the actual possible rational roots are just the combinations of these. So plus or minus 1, because 1 divided by 1 is still 1, and plus or minus 3. So those are my possible rational roots. Now I want to use those to actually help me find roots. We're going to go to the calculator for this. Okay, so here I am with my calculator. I'm going to go ahead and put the function into y equals. So let's put in x to the third plus 6x squared plus 10x plus 3. Now what we're going to do is we're going to graph this, and we're going to look to see, do any of those possible rational roots look like what we were trying to find? And in this case, I can see, well, I got some root here between 0 and -1. All right, so that must not be a rational root, but it looks like maybe at -3, I have a rational root. Now, it also looks like maybe there's a bounce there, which, remember, there means there's a multiplicity of 2, but maybe there's not. But this is what we're going to explore. So the idea is, we looked at the possible rational roots. Now we're going to look at the graph to help us narrow down, okay, -3 looks like it might be a root. That's where we're going to start. Now you might be asking yourself, what do you mean that's where we're going to start? Well, remember what we already learned from the past couple days' lessons is that if we do synthetic division by a number and we get a remainder of 0, that means that we actually found a root. So we're going to start trying to do synthetic division with -3, and if we get a remainder of 0, then that means our intuition was correct and -3 is an actual root. Then we can use the reduced polynomial to help us find the other roots. So let's go ahead and do that. So I'm going to do -3. Coefficients are 1, 6, 10, 3. So I'm going to pause here. I want you to try and do this synthetic division on your own. So pause the video, unpause when you're ready to check your synthetic division, and then we'll move on from there. All right, so hopefully you did your synthetic division correctly. We add vertically, we multiply diagonally. So 1 plus 0 is 1, 3 times -1 is -3, 6 plus -3 is 3, -3 times 3 is -9, 10 plus -9 is 1, -3 times 1 is -3, 3 plus -3 is 0. This is good. We got a remainder of 0. That means that yes, -3 is a root. That's awesome. That's what we wanted. Now, we have to think, how do I write this result? So remember, the original polynomial was third degree, so now this is a second degree polynomial. So our result is the polynomial x squared plus 3x plus 1. Okay, what are we going to do with that? Is that our answer? No. Good question, but the answer is no. Why is that not our answer? Well, remember, the original problem wants us to find all of the roots. So we know that since this is a third degree polynomial, again, we talked about this the other day, if the degree is 3, then I should find 3 roots. I have only found 1 root from my calculator. I saw a couple others on the calculator, but I don't know exactly where they are. They're clearly not rational numbers because it was not -1, +1, or +3. So how do we find roots from this? Well, this is another factor of the polynomial. Since it's a factor of the polynomial, to find roots or x-intercepts, I set it equal to 0. Now I want to try to solve that. Does anything multiply to 1 and add to 3? No, it doesn't. Good question, though, but it doesn't. But that's what we want to try and do first, is factor. It didn't factor, so now we have to either complete the square or do the quadratic formula. I'm going to let you choose which one you want to do. Go ahead and either complete the square or do the quadratic formula with this. Pause the video, do that work, find the remaining zeros, unpause when you're ready to check. Okay, so whether you did the completing of the square or the quadratic formula, you should have ended up with an answer of x equals -3 plus or minus √5 all over 2. Here's my work for the quadratic formula. Again, completing the square should get you the same exact answer. So now we need to make sure that we answer the actual question, and the question was, what are the roots? So the roots are x equals -3, x equals -3 plus √5 over 2, x equals -3 minus √5 over 2. Any questions? All right, nice work. Let's move on. Okay, I'll give you a minute to write down this function, but then we're going to go ahead and find the possible rational roots first. So I want you to go ahead and write down the function and then find the possible rational roots. Pause the video, unpause when you're ready to check the possible rational roots. Okay, so here we see that our constant term is 2 and our leading coefficient is 3. So I think about, what are the factors of 2? They are 1 or 2. What are the factors of 3? They are 1 or 3. So now I just list out the combinations of those. So I could have 1 over 1, 1 over 3, 2 over 1, or 2 over 3. Remember, 2 divided by 1 is the same as just 2. So my possible rational roots are 1, plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3. Let's go ahead and put this into our calculator so we can see, well, do any of those appear to show up on our calculator? All right, so I've gone and put this into my calculator, x to the third plus 2x squared plus 3x plus 2. Let's go ahead and look at the graph. This is exciting, I know. Okay, boom, I see I have a root right here. It's between 0 and -1. So what are my possible roots between 0 and -1? It could be -1/3 or -2/3. Now, if I look at the calculator, I'm going to say that it looks a little bit closer to -1 than it does to 0. So my instinct then tells me that it's probably the -2/3. If it's not, that's okay, then we could try the negative 1/3. But to make my essentially guessing more efficient, I'm going to try the negative 2/3 first. So let's go ahead and do synthetic division. Negative 2/3. Got my coefficients, 3, 2, 3, 2. Again, I'm going to have you pause the video here, do the synthetic division on your own, and unpause when you're ready to check your work. All right, so we did the synthetic division. Hopefully you ended up with 3, 0, 3, 0. That's correct. Again, add vertically, multiply diagonally. So 3 plus 0 is 3. Negative 2/3 times 3 is negative 2. 2 plus negative 2 is 0. Negative 2/3 times 0 is 0. 3 plus 0 is 3. Negative 2/3 times 3 is negative 2. 2 plus negative 2 is 0. That's good. I got 0 as a remainder. That means that I was correct. Negative 2/3 is one of my roots. Now again, how do I write my answer? Well, I ignore the remainder because it was 0. Since the original polynomial was third degree, then the result, or the quotient, is second degree. So this is the coefficient on the x squared. There is 0 x terms, and so then it's plus 3. Now I already set this equal to 0 because we need to still find the remaining roots. So to find the remaining roots, we set this equal to 0 and we solve. Let's go ahead and do that. I'm going to end up with x squared equals negative 1. Now if I take the square root, what's the square root of negative 1? Very good. Plus or minus I. Excellent. So my roots are x equals negative 2/3, x equals I, and x equals negative I. Now I want to point out, this explains, so we got negative I and I as our two other roots, so we have 3 total roots, which is good because it was a third degree polynomial, but the fact that these two roots are imaginary explains why we only see one root on the actual graph. Because remember, imaginary roots are not x-intercepts. So we have only one x-intercept, but we have 3 roots.